Okay, hello. Sorry for late start today. It was a series of things going comically wrong. All right, looks like we're getting connected here. I'm trying to double check, make sure everything's working right. Last time we had some problems on a couple of the streams. Okay, that's working. All right. So anyway, yes, hello, greetings, welcome. All right, and we have audio. Okay. Hey, it's Boyan. Good to see you, Boyan. Good to see you. Yeah, the beard is coming back. I was in the Netherlands for Delphi Summit and decided to tack on a couple extra uh, days to tour around a little bit in Europe, which was fun. With my daughter came with me, and I forgot the charge cord for my razor, you know. And so I was like, dang it. And so I went to buy a disposable razor. And my daughter's like, hey, you're on vacation. You can just let it grow. And I'm like, all right. So, yeah, right now I am beard, incoming beard. I think I've just passed the awkward unshaven stage to the looks like I'm growing a beard stage. Anyway, enough comments about facial hair. So again, sorry for the late start. There was a I don't know what happened. It was a combination of things. I usually like to be on really early, but for some reason, I think maybe it's a time zone thing or something. I was off on my timing for what time I thought things were going on, and then the on the way into the office because I came into the my co-working space here today, which has got the nice soundproof, or you can see the whatever it's called, anechoic chamber. I the traffic was horrendous, and then I couldn't get logged into the system. So anyway, enough about that. Thank you everybody for joining. Give me 1 second here, and I'll fire things up, and we'll get going. One. So I'm using a new what's it called? Presentation software, and I'm not sure if am totally happy with it or not. It is Markdown based, and so you create your slideshow in Markdown. All right, let's see. Share screen. Let's say click here. Nope. Hopefully I'm pointing at it. Guillermo, hello. Juan? I'm sorry, I'm terrible at names. Great. All right. Well, great to see everybody joining in here. Let me see if I can swap this. I do a. There we go. That's a little better. All right. So a little bit down in the corner. Introduction to debugging with Delphi. So this kind of evolved a little bit into some general debugging topics as well as Delphi specific, but hopefully I think it will be a really interesting topic for everybody. If you do have questions, put them in the question panel there. If you did happen to join this without visiting, let me bring that up here. The link down here at the bottom, mailing.gdksoftware.com/webinars. Do go down there and sign up. That's how you will get notification about future webinars in the series, as well as the replay, or I guess links to the slides and stuff like that. So go down there and sign up. I want to make this. I don't like gating webinars. I want to make them as available as possible. That's why I stream them into multiple platforms. But if you can come out here and check that out, grab that, then that way it will make it easier for me to get you all the, and there's a QR code up in the corner too. I think I'm pointing in the right direction. It's probably mirrored, so it's probably that way. Yeah, so go out there, grab that, and then that way you'll get the access to the slides and everything. And there's quite a bit in the slides, as usual. I got carried away. So grab that and sign up there, and we'll get started. So this is Introduction to Debugging in Delphi. I'm Jim McKeeth from GDK Software USA. If you're not familiar with GDK Software, we're a Delphi consulting company. We provide services related to Delphi development. We have, I think, close to 40 Delphi developers across our 4 offices, and we focus on Delphi. So if you're looking for additional capacity or some expertise or a second set of eyes, then definitely check us out at gdksoftware.com, and we'd be happy to work with you. That is not the right agenda. Oops. Like I said, I'm experimenting with a new markdown-based system, and apparently I had some stuff that didn't get cleaned up in it yet. All right, introduction. So I always like to try and quantify things, and I was thinking, what are the reasons for code to change? And the reason you're writing code or your code is changing, it I think falls into these 5 categories. You have your initial development, which could be prototyping or proof of concept, but this is where you're starting out from scratch, you're making something new, greenfield development. Then you have feature work, which is where you're going and adding features to an existing project. You have refactoring, which is when you are adding functionality to not adding functionality. Sorry, you're changing the code without changing functionality. So, which is kind of seems odd, but the idea behind refactoring is when you're doing refactoring, you shouldn't be changing the functionality. The functionality should be exactly the same. Sorry, somebody. Important message came through. So you're changing your code without changing behavior. The functionality shouldn't be changing when you're doing refactoring. Refactoring should just be cleaning the code up, like for example, let's say you have one class that does too many things, and you're like, you know what, this should do just one thing, and you separate that out into multiple classes or multiple units or whatever. That would be your refactoring. So you're not changing the functionality from the program execution point of view. It's the same, but you change the way the code works, or change the way the code is structured from a maintenance point of view, giving things more meaningful names, things along those lines. Then you have upgrading maintenance, which is when your libraries or your tooling changes and you need to upgrade things. And again, this is similar to refactoring in that usually you're not adding functionality in at this point, but it's different from refactoring in that it will probably change the finished product, the program. The program's functionality will change because of the fact that you've changed the libraries or tooling. So, for example, new version of Delphi comes out. You are usually it's pretty painless to upgrade, but occasionally it does take some effort, and there are some changes that happen, and so that would be in that situation there. And then the 5th category is debugging, which is where you're removing bugs. Now, the important point here is that all 5 of these reasons for code changing introduce bugs. Now, not every change introduces a bug. There's a ratio, and that ratio is going to vary depending on the type of work you're doing, most likely. Feature work is probably more likely to add bugs than debugging, for example. But any type of code change you're making has the potential to introduce bugs. So that there's actually metrics you can develop over time with your team where you can look at the type of work you're doing and say, what type of work it is, how much is being done, and how many bugs are going to be produced as a result of that. So that's an important thing to keep track of in order to eliminate bugs. Because yes, even fixing bugs can introduce new bugs. So that's why it's important to have unit tests, which we're not really going to get into a lot today. But unit testing is a great way to make sure you haven't introduced new bugs or make sure you haven't got regressions. That's the great thing as far as regressions. Is to make sure that you haven't broken something that you've already fixed. So some general best practices. These apply all the time, even when you're not debugging. And this first one's really important, and I have a story to share. I had it's called a Chesterton fence. If you've never look it up, Chesterton fence. So Chesterton fence is this guy goes to the council and says, "Hey, there's this fence that's bugging me. It doesn't serve any purpose. It's obstructing the view of the landscape. We should take it out." And the council says, "That fence was put there for a reason. Find out why it's there before we remove it." And so that's the point, is that if you don't know the reason something's there, you don't remove it. And so this story that I had a developer on my team that was going in to fix a bug, and he's like, why is this here? This shouldn't be here. This is just silly code, and removes it and introduces a bug in the process because he was making a change unrelated to the task at hand. So whenever you're doing development, you should be doing a single thing, right? This is the same thing with our code, right? Our code should be doing a single thing. You should be doing a single thing. If you're in there doing one thing, get that one thing done, do that one task, make a commit to source code of just that one task. And that way you're easily able to go back and look and say, oh, this code change was related to this task. If that was a problem, you can then revert that back. Always address all hints and warnings. Use source control, unit tests I mentioned before, and then your best practices in the way your code is written and structured is always important. All right. So what is debugging? Identifying and fixing code. And I've grouped some of these maybe in here that maybe you wouldn't call debugging. For example, upgrading and maintenance I've put in here as well. But it's going in and fixing errors, improving code quality, optimizing performance, reliability, etc. So when you're identifying and fixing errors, this is kind of your traditional debugging. So this could be that QA or testers or end users have identified a bug and submitted a ticket or a bug report. I should say bug, not but. The markdown editor I'm using doesn't have a spell checker. I discovered one disadvantage to using a markdown based system. So as a developer, though, you may need to validate the bug exists or that it is in fact a bug. Maybe it could be a mismatch user expectation, which is a bug in its own right. Then you're going to go in and surgically locate and resolve the reported bug, and then verify the functionality. Improving code quality, this is refactoring. This is where you're going in and changing code without changing behavior. Optimizing performance, you're going to use a profiler or other measurement tools to find out where the execution time is high. And you're going to use this formula down at the bottom to target where you're locating at, right? You don't want to just target slow code. You want to target slow code that executes frequently and impacts the most users, right? So if you have a very slow routine that one user runs once per month, that is not as important as a slightly slower routine that is executed multiple times by many users, right? So that's why it's important to use tooling, use a profiler in order to locate the where the bottlenecks are, and then look at what the impact is. Yeah, so debugging is essential for creating high quality software. You want to identify, analyze, and fix bugs. I was moving things around here. Okay, yeah. So there's some different types of bugs you might run into. You have incorrect behavior, like we call them, implement profile. Okay, I will show you. We'll do a little bit here with profilers in shortly, but implement a profiler in the Delphi IDE. We'll get to that. All right, so the different types of bugs. You have logical errors, which is incorrect behavior. So this is where you the program was intended to have a certain set of behavior, but it behaves differently. And that incorrect behavior, or sometimes called undocumented features, is just where the program doesn't execute according to its intended specification. A runtime error could be a logical error or whatever, but it produces some sort of crash. There's an error message that is generated. This is where tools like mat accept or Eureka log come into play, where they can grab that crash error message at runtime when it's being executed and provide that back to you, so that it could be out running on a end user computer, and that it can grabs that the stack trace, the details about what the user is doing, so that you can then use that for debugging purposes. Because most likely, in your internal testing, in your internal use, you did not encounter that, or you would have fixed it. And so there's something that happened there, something that led up to that you were not aware of. So that's why it's great to have a tool like that can capture that for you. You also have user expectations. And this is an interesting one in that, you think about, there's the three parties involved in a program, right? You have the developers, right? You have the project manager. Now, you may be both the project manager and the developer, but usually there's somebody that, like with the architect or whatever, that defines the vision of what the program should do. And then you have the users. Now, it's possible all three are one person, right? If you write software for yourself, you wear all the hats. But there are times when the project manager is like, okay, these are the functionality we're going to do. The developer implements it perfectly, of course, right? And then the user gets it and they're like, this doesn't doing what I'm expecting it to do. And so you have to decide, right? That's a user expectation mismatch, right? Does it need to be documented better that, hey, this is not a feature of this program, it's not what it does, it's not how it behaves, this is how it behaves? Or maybe the user experience, the UI, needs to be improved, clarified, so that the user doesn't have a mismatched expectation. Or it could indicate that the project manager forgot a feature, right? It's like, oh, that is a totally logical way, that something we should have done, but we just did not think of it. And then that would be a bug that needs to be fixed. There can also be incompatibilities, which could be an external change. For example, a new version of our operating system comes out with new requirements, a database you're using changes, an external API changes, or whatever, and create some sort of incompatibility. And then performance as well, which is when your application is not as fast. Now, I was thinking about this one. Usually, over time, your hardware gets better, right? So if you write a program and that program is being used, and over time, the hardware is going to get better and faster. So usually performance is not going to degrade on an application. It degrades on an application when you introduce new features, I guess, that are not as performant. You make changes to the application that require better hardware that doesn't exist. So when you have a user that's using your program on an older piece of hardware, and then you add features thinking everybody's on newer hardware, faster hardware, then that's when you just introduce performance bottlenecks that way. But the other thing that can happen, and I've actually seen this happen, is that you can have a program that you've developed that can be mature, it can be static, where it's not really changing. But then over time, the way users use your program, they can become more demanding on the application, where they're adding more data, where they're doing more with the program, and then the speed ends up becoming a bigger issue, where it's no longer right. The way the application performed is no longer adequate for the amount of data that the application is dealing with. And so then that's a case where you could have a degraded performance over time that's not a result of you introducing things expecting higher end hardware. All right, let's look at debugging in the IDE. Kind of covered some of the basics of debugging, some of the general concepts, but let's look at some actual practicality in the IDE. So give me a second here and let me get my where's this at? It says, oh, okay, there it is. So usually I like to come in and get an early start on these, so I have everything set up, but because I got in here late with everything happening, I did not get everything set up ahead of time. So give me 1 second here and let me make sure my so I will answer this question here you had about implement a profiler in the Delphi IDE. There is a so you can actually I will show you there's a few profilers that are available to specifically work with Delphi. AQ time is one, and actually let me bring up a oops, let me share that screen. There's AQ time by SmartBear. It's a memory code coverage performance profiling tool for Delphi as well as other languages. So that's one that's available. Then there's, oh gosh, I'm totally spacing what the other ones. Man, you know what? I did a another. Oh, I don't have that here. Gosh. You know what? I'll just do this. Delphi code profiler. So there is VTune by Intel. Yeah, so Spider's a profiler as well that's out there. There's AQ time. There's a few open source ones up on GitHub. All right, so here he's just using a oh, here we go. Links to few. Okay, there we go. GP profiler, Pro Delphi, AQ time. Okay, so I'd heard, I'll put that up there. So Lance said, I'd heard a couple people say this, and I have not verified it, but now that I've heard enough people say it, I will go ahead and repeat it, that apparently AQ time is being phased out, which when I went, the website didn't say that. So yeah, apparently it's being phased out though. So yeah, not being updated. It's the latest version of Delphi. You can also use, there's a VTune from Intel. Which, so this one, it gives you like a much lower level look at the performance. So for example, oh gosh, I covered this last week actually in plugins, but there's a PDB to map, I think it's called. VTune P. I may have that backwards. Yeah. So there's a utility map to PDB. That's what it is. I did have it backwards. That takes the map file that Delphi generates and converts it to a PDB so that you can use it with VTune. vTune gives you a much lower level look at the way the code's being optimized. So anyway, here's a few other ones here. Nexus Quality Suite is a good one as well. I met the Nexus team up at Delphi Summit. That was kind of cool. Sampling Profiler. Anyway, so there's a few profilers. You can do this also without third-party tools as well, which I will touch on briefly too. All right, it's my IDE. It's restarting. Let's see, any other questions? If you have any other questions, go ahead and put them in the question panel here, and I will answer them as we go along. Come on, let's go. So after my Delphi plugin session, I did let's switch back over to, I had installed AQTime, or not AQTime, GExperts, because I hadn't used a lot of plugins for a while. When I worked for Embarcadero, I'd like to keep it plain without additional add-ins. And GExperts has a feature that I'd forgotten how much I like that tells you if there's 2 instances of GExperts running, which is a way of letting you know if you've got like you launched the IDE twice by accident, which I do occasionally, and I just did it again. But I discovered that if you install something via Git Package Manager and then Git relaunches the IDE, that it launches it before it makes a new installation, or it makes sense if you think about it, right? It launches the IDE and then has to shut down the existing one, which then GExperts pops up and says, hey, you have 2 instances running. So, okay. I think I have a couple. Yeah. All right. So I don't know that I got this one. Let's see if this. Okay. So here's the IDE for debugging purposes. Oh, that fixed out really well. My picture down in the corner is not covering up any important parts of the IDE. I just wanted to kind of break down some of the different parts of the IDE here that you use when you're debugging, and we'll go into more details when I go into the IDE. Actually, let's just go into the IDE. I don't need to do this in slides. Let me lay this out differently here. And switch screen sharing window. There it is. Oh. Okay, so you should see my IDE now, and I've made it a little bit smaller, so now my windows are all kind of scrunched up. Oh, that's the wrong one. Okay. All right, perfect. So, is it debugging right now? Oh, I did launch without debugging it. Okay. So you can get your debug layout up here. You can change between default layout and debug layout. And of course, it remaximized itself. All right, that's fine. We'll just leave it maximized. Yeah. So you can switch between this by all right. So your default layout is when you're writing code, and you have your debug layout where it changes some of the windows out. So you have these windows over here. You can customize this, which I encourage you to do to get the right layout for you. But then also when you run the program, right? So I'm gonna switch back to default layout. And when you run it in debug mode, which is the one with the little ladybug next to it, it's going to then switch to your debug layout. Now, that's not, these windows are blank right now because we're not actually debugging. The program's running and you have no breakpoint set. But let's go ahead and here and set a breakpoint. So that's the first thing I want to talk about is breakpoints. Now I've done the, let's see, not here. Let's set it. All right, we're going to put the breakpoint in here. This is a draw event that I'm doing in drawing a cell in my application. So it'll be triggered immediately once I bring the application back in the foreground. There we go. So if you've ever put like a show message in your application to say, what's the value of this variable right here? This is gives you a way to do that without having to add that to the code. So I can come in here. Now the keys you need to know about, there's buttons for right here. There's trace into, step over, and run until return. These are the big ones here, is step over, trace into. So F8 is step over. So it just steps down one line. And then I can use the mouse to go in and say, what is the value of that, right? I can mouse over these and see what the values are. You can also come in and right click on it. Okay, so actually you can mouse over this guy here. This is a record, and I can expand it out and see all the values of that record, which this is the color record. So it's got like all those constants in it as well. And you can nest in multiple layers. They can also come in here and say debug inspect. And that brings up like a object inspector type view of the record and let you scroll through and see things. And so here's the RGBA that I was setting in there. And I discovered, actually, I'll share an interesting tidbit here. This is a color rec, not an alpha color rec. And you'll notice it has an A for alpha. If you, all right, I've gone down this rabbit hole, so I'm going to keep going. If you dive into this code, so if I hold control and click on this, it will take me to the declaration for it. And so the color rec you use to maps to a T color, okay? And if I go to T color right here, you see that T color is a 32-bit number, but it doesn't allow the maximum value. See, it's got this 7F here. All right. So if you, in your color rec, because it's a variant record, if you set this alpha value, this A value too high, then it can go beyond the 7F, right? So if you set the alpha beyond 7F, it will actually get a range check error on the thing. So I don't know why the alpha's in there. I haven't dug into it yet, but I just discovered that and thought that was kind of odd because I was having this weird error message in my program. It's discovered it was because when I moved between an alpha color and a regular color, if the alpha channel was beyond 7F, then it caused an error. Anyway, some of the weird things you discover when debugging. Oh, the expanded view is not showing up. Oh, thank you for letting me know. All right, let me change the way I'm sharing this and see if I can get that to show up. Let's see, share, play screen sharing, window, let's go entire screen. All right, so I have to share the entire screen, which means that when I bring up the thing to look at the chat, you're going to see the chat. Oh, well. Okay, so I'll show the expanded view again real quick. So there's the hint on just the individual one, but then if I bring over here, like that, and you can scroll down and see the values. Oops. That's kind of a pet peeve of mine, especially web apps that do this, where they have these fly out menus. If you mouse out the wrong place, it goes away. Yeah, so there I can see those values there. So see right now, the high word is B and A, and right now it's just got the 7F from B in there. But if I was to add an alpha value to it, then that's when it would go beyond right? So if it was beyond 127 in that alpha channel, then it would get a range check error, was what I was referring to. And then, all right, so now I go in here and do the debug inspect. And here is a more persistent view where I can go down and see these values here. And the other thing I want to show you is the evaluate modify, which is when you're like running your program and you want to see what would happen if this was a different value. So I can come in here and say, oops, I want to do it on the RGB, debug, evaluate modify. And so now I can come in here and change it. Oh, I can't change the debug value of R. So I can come here and change the value of R to, we'll say 255. All right, and you'll notice over here, it was updated as well. So I'll change it. So this is the local variables. So see right here where it says 255, when I hit modify, you change it to 127. And we see the high word and the low word also changed. So this is a really useful window. This is going to show you the value of all the variables that are local within your current scope. So right now in this method right here, I'm going to see all those variables values. And then the third window on the left here is your watch list. And so your watch list can be particularly useful if you want to track something that is going to be not just a local variable. So for example, FD query red value is not a local variable. So I can put that here. And let's put those three there. And I can see those values, right? But then I can also see those values when I'm in a different method. So let's go here to this next one, the title click method, and I'll put a breakpoint in there. So I'm going to go ahead. Oh, one last thing I want to show you here. Actually, yeah. So RGB, we've modified red, right, to be 127. I'm going to go put a watch over here for this so that it's easier to see. And you can edit these by double clicking on them as well and bring up the little editor here where you can change the way you want it to be displayed. And I believe, and I know Boyan's in the chat, Boyan added a debug visualizer for colors, so you can see colors, which is a very nice thing here. So when you're doing a T color, you can see what would visualize the color. I may be wrong, but I think Boyan added that. So there are a number of third-party can make additional debug visualizers that can show up on the right. Actually, let me do this. I'm gonna make another one here. I think it's RGB.color in hexadecimal. Yeah, so that I can see the hexadecimal representation, which then I can see like there is, 7F is red, 6C is green, and 7F is blue. All right, so this is a cool thing here. So if you notice, my mouse changes into a hand when I go over this little bar here on the right. I can actually grab this and drag it up here, and it changes the execution point of the code. All right, so remember I changed the RGB because the red record is 0, but I had changed it to 127, and so now I'm going to step again with F8, and we'll see it is now changed back to 0 again. So that way you can actually do like check different code paths in your program in one go, which is, I think, a pretty useful thing. Let me check the questions real quick, see if there's anything I need to. Okay, good. All right, so I'm going to go ahead and remove this breakpoint and go to the next one, which is when I resort. There we go, title click. So now you can see that this RGB red doesn't exist because it was declared as a local variable up here, see? And so because it was a local variable, it is out of scope here, and so I can't see it. But these other ones, the red, green, and blue records of the table, the data set, are visible still. All right, and my local one here changed as well, but you'll notice because of inline local or inline variable declarations, even though sort column and IDX are declared within the scope, they're not accessible yet because I'm before they existed. So I'm going to go ahead and step over here and see. Now we see that one has a value. And let's see. Oh, here we go. And now IDX has a value as well. I do want to look at the breakpoint screen here. Let's go to breakpoint properties. This is one of those things that when people, a lot of times when I show people this that are new to debugging, this is where they get like blown away. You can come in here and you can say, I want to break on, and you can write an expression. So when, for example, you can define a value of a variable, a variable is greater than something or less than something. You can say, I only want to break after so many executions, right? So when after the, so let's say you have a loop, a really long loop, and you're like, I don't care about the first 10,000 iterations of this loop. I want to see the 10,000 of first iterations. You can go in here and say pass count 10,001, and then it'll break on the 10,000 of first iteration. One comment about this is that it does impact the performance of your application to have a conditional breakpoint because it has to evaluate that. So if you have a really, really long or something that takes a long time to get to the point where it's going to trigger, like for example, the 10,000, it will slow down those 10,000 iterations because it has to evaluate the pass count on each one. You can set up breakpoint groups that you can turn on and off, and you can also attach a breakpoint to only be executed if it's happening within a certain thread. You can go even further with this. You can have a breakpoint when it executes. You can say, when the code gets to this point, I don't want to break, right? So I don't want to stop execution. I just want to keep going. But I do want to turn off exception handling, or I do want to turn exception handling back on, or I want to enable a different group of exception or different group of breakpoints. So you could define a some breakpoints, right, that you don't want to keep breaking on in most situations. But then when this line of code over here executes, then you come in and say, so you take these breakpoints, you put them in a group, and then you have this other breakpoint that you say, I don't want it to break. You turn off breaking on it. And then you want to say, I want to enable this group of other breakpoints over here. And so what that does is it gives you a better circumstance. So let's say, for example, you have some breakpoints like in that loop, right? That on the 10,000th iteration, there's a code path that executes. You can put a breakpoint in there that says, okay, when this code path executes, don't break, but instead enable this other breakpoint, and then it will enable that breakpoint. You can log the call stack. I haven't used a lot of these log messages. This one's useful. You can have it add a message to your message window, whether it could be like a value. This could evaluate things. You can also, it's been a long time since I did this, but response to the question about how to implement code profiling in the IDE. It's a little fidgety, but you can actually come in and put a expression in here that creates a high resolution timer. All right. So you can execute a high resolution timer create in one exception or one breakpoint. So you can take a breakpoint, turn off the break, have the high resolution timer start, and then have another breakpoint that the high resolution timer stops, and then log the response of the high resolution timer. So you can implement a poor man's code profiler in the IDE using non-breaking breakpoints. I wrote an article, blog post about it 20 years ago, so I don't remember all the details. I might be able to dig it up. If you search for code profiling with non-breaking breakpoints, you might still find it. But yeah, breakpoints, super, super powerful. What you can do with that there. Oh my goodness. We are running out of time. So I do want to show, so the call stack shows the path that how you got to where you're at. So this could be particularly useful, like if you're have an exception and you go in after an exception happens and you're like, how did I get here, or what did I get here from? You can see your call stack. And the interesting thing here is I can see, like right here, do mouse up, right, had a parameter of MB left. This is the sender. This is the address of the sender. So it's useful that it shows the call stack and it shows the parameters so that you can see what was the values that led to that point where you're at now. There are so many other useful things in here. Debug windows. So here's where you can enable or disable groups of breakpoints. So this lists all the breakpoints in your application. I put a new breakpoint in here. It shows up here. You can have the condition on the breakpoint, the group name, and then you can enable and disable different groups. Let's see, delete breakpoint, add breakpoints. You can have, this is introduction. All right, I don't need to cover everything. Disable all breakpoints. Okay, so it doesn't have a group enable breakpoints, but you can put groups on it. But that's the reason you put groups on breakpoints, is so that one breakpoint can enable a different breakpoint. Although, gosh, I thought there was a, yeah, right here. If you have it in groups, enable and disable groups is right there. View debug window. Our watches is already up. Local variables, threads. Here's a list of all the threads in your application. And you can actually do things where you can freeze the threads, freeze other threads and stuff like that. So if you're dealing with multi-threaded applications, which I will point out, this, I have not introduced any threads in this. All these threads are threads I got for free. So do be aware that even if you don't think you're writing a multi-threaded application, you are writing a multi-threaded application. This is a really, I think is a cool view here, is you can go to the disassembly view, where this shows you the machine code, the assembly representation of the machine code, and your code all at the same time here. So this can be really useful. Oh, apparently I'm over my time, so I got to wrap it up. I only reserve the studio through the top of the hour. So let me stop sharing screen. All right, I will, since I'm over time, you can, I'm going to send out the slides and that'll have all the details in there, and I'll expand it out with some more details in there. Anyway, apologies for the late start. Apologies for going over and have to cut it short, but thanks for joining me. And do go out to the mailing.gksoftware.com/webinars and sign up for more webinars in the series. And thank you very much. And I will see you next time. Take care.